What we have here is a 3D printed wind farm with each turbine containing a number of sensors to detect things like humidity, temperature, and vibrations that help us perform predictive maintenance. All of this telemetry data is being sent into the cloud using AWS IoT Core for turbine connectivity and management. It additionally allows us to route telemetry data to a number of destinations such as AWS IoT Sitewise, where we can collect, process, and organize our data. From here, we can start to visualize our data in a number of different formats. Here we have a dashboard hosted in AWS Managed Service for Grafana that allows us to visualize our telemetry using graphing and charts, but it also has an embedded digital twin built in AWS IoT TwinMaker. As you can see here, we have two TwinMaker scenes embedded in our dashboard. One is a virtual representation of what we see in the physical world. If we zoom right in, we can actually see motion indicators animated around the nose cone, which represents turbine movement. On the right-hand side in this scene, we can see the turbine's internals. This allows us to potentially shade or indicate problematic hardware once it's detected, so that operations are able to identify the exact problematic hardware instantly and begin remediation work. If we scroll down, we can see other aspects of the dashboard with data coming in near real time with approximately 5 seconds of lag. We're able to see the health of each turbine with information on vibrations, temperature, and humidity, in addition to the power generated in the form of RPMs and power produced. The turbines are currently operating normally. However, let's take a look at what happens when vibrations climb to abnormal levels. In each of our turbines, we have a mini vibration motor that we can activate for a brief moment by sending an IoT payload. As we can see, the vibration has increased significantly on that second turbine, resulting in a spike in our dashboard. If we take a look at our digital twin scenes, we can see which turbine is specifically affected as it's shaded red to indicate a general fault with that turbine. If we take a look at our other scene, and we zoom in on the internals, we can see which of the hardware within the turbine is specifically affected, and in this case, it is the vibration sensor. This lets our operations team immediately understand across all of their wind farms and turbines what they need to investigate and remediate. While this is a useful way to determine internal abnormalities, we still need a way to look for external issues that need to be addressed. If we scroll to the bottom of our dashboard, we can actually see a section which has been collapsed for drone inspections. Given the size of turbines in production, it can be hard to get up and close to do a visual inspection, so UAVs or drones can be used to perform those inspections. Some of the challenges with UAVs are being able to navigate to the appropriate waypoints, especially in an autonomous fashion. Getting the wrong waypoints can be disastrous if the drone flies directly into the turbine. A safer way to test flight paths are to use simulations. Photorealistic simulations that emulate real-world physics can be built using a number of different simulation engines. This one that you're seeing here was built in Unreal Engine, and it allows us to test flight paths, ensuring that they're correct prior to using them on real-world drones. Another benefit of photorealistic simulations is the potential to build computer vision models, given how realistic engines like Unreal and Open3D Engine are. We can potentially build computer vision models to detect all kinds of abnormalities, such as maybe birds' nests, turbine blade defects, or even things like rust. Once we've got our waypoints configured, we can implement our flight paths in the real world and attempt to navigate our turbines, collecting imagery to then process for anomalies. Alexa, open Drone Inspector and begin the turbine inspection. In this case, we've got a voice-activated drone using Amazon Alexa, which takes off and navigates autonomously around our turbines. You can see it doing so in the top left-hand corner of the screen. It's providing a low latency video feed to our Grafana dashboard, as you can see in the rest of the screen, that allows us to perform a near real-time visual inspection. However, we're also able to use computer vision to automate some of the inspection. As you can see, we've got a second panel in our dashboard that will display anomalies. What's happening here is we're slicing our video feed into 1 frame per second and submitting those frames to AWS Rekognition that has a model trained using custom labels. We've uploaded and labeled photos of healthy and unhealthy turbine blades in an effort to have the model annotate them appropriately for us once a flight is complete, and show them to us via our Grafana dashboard. This automates some of the external anomaly detection tasks for wind farm operators.